Welcome to the lecture video of Fourier transform. In this video I will talk about the transfer function using the differential equation. Actually, first of all we need to know the what is the meaning of transfer function. Basically in electrical engineering we know transfer function is the ratio of the output and input of a system. So in this content you should determine the response of the of a system, and you need to determine the transfer function. So if we want to solve this problem, in this problem you are being asked that find the impulse response or transfer function and the output yt. If xt this is the input actually for a system, actually yt, if yt is the output and xt is the input, where xt is given by that, and the system is represented by the second order differential equation. In many times when we see the problem of control system like that, in sort of example of control system or second order system, electrical system, we can formalize or we can present the system by the differential equation. So here the second order differential equation in case of a system, this second order differential equation present the overall actually related. It would be better if we call the system related by the differential equation, and the more I will discuss in later. So what would be our ultimate goal? Our ultimate goal is to determine the output time domain, that means yt. But in this equation yt yt present as the output, and we need to actually determine by the Fourier transformation process. So this is the property of Fourier transformation. We know that the Fourier transform of any or differential term in any order, here we can see d to the power n, in nth order differential equation can be Fourier transformed by simply writing x omega with j omega to the power n, as we have seen in some cases in earlier videos. So if we have the Fourier transform of xt is given by x omega, we can determine the Fourier transform of nth order differential term by just multiplying the x omega by j omega to the power n, where n is the nth order of differential here. So here this term is second order, so if we transform this equation to Fourier transform, then we need to write j omega square y omega as we have discussed earlier. So here 5 j omega y omega. So why we need to y omega? We need to write y omega for the y by using this property. Actually you can compare, you can see here. So if we have the Fourier transform of yt is y omega, so in this fashion we can write the Fourier transform of this equation. So our ultimate goal is to determine the y omega. So after taking the common part y omega, j omega square plus 5 omega, it is very easy, it would be very easier for you. So after that y basically the transfer function, as I have said, transfer function is nothing but the ratio of output and input. So y omega is the basically the output of the system in frequency domain, and x omega is given by the input of the system in frequency domain. So these two ratio can be determined from this equation. Basically y omega divided by x omega is equal 1 divided by from this equation it is very easier to determine. So ultimately one of the part of this question is solved here. In that question you are asked to determine the transfer function or impulse response. Basically this is the impulse response in frequency domain, so S omega should be determined. And another part, you need to, when you need to determine the yt, so this y omega need to transform. Actually you need to take the inverse Fourier transform. So when you need to when you have to determine the transfer function in frequency in time domain, so you need to take the inverse Fourier transform. Here this is the second order equation. In similar fashion, in previous slide or previous lecture I discussed, you need to convert this in this fashion, and after converting this partial fraction, you need to determine the value of constant, and after putting that AB like fashion, then you need to determine the inverse Fourier transform. And this is the Fourier transform we maximum time we use that. So the inverse Fourier transform of that part is that, that part is that. So finally we will get the Fourier transform of S omega is HT. So what the significance of HT? HT nothing but the impulse response of the system. So when you will be asked to determine the transfer function, you will determine that. When you will be asked to determine the impulse function, impulse response, this is the case, this is the function you need to determine. So and the second part, when you will be asked to determine that determine the yt when the input is something like that, when the value of input is given, then you need to put the value of xt. Where you need to put the value of xt? First of all, you have actually you have determined the value of y omega from here, so you need to put the x omega. So where will you get the x omega? X omega nothing but the Fourier transform of xt, and xt is the input of the system. So here in this case xt is e to the power 40 ut, so you need to transform it to Fourier transform. So we know e to the power 80 as in this fashion. So the Fourier transform is that. So when you put the Fourier transform of x omega replaced by 1 divided by j omega 4, this would be the case, you will get the y omega. So in the similar fashion, you need to transform ABC fashion, partial fraction. So after having this value of ABC, you can finally be able to determine the output of the system. This is the procedure to determine the output as well as the impulse response and the transfer function. So the main question will be arising to your mind, that how could we determine the value of ABC? So I want to mention again that in the previous case, in the previous video, I already discussed how to determine the value of ABC, and this is the basic thing actually you learned in math course actually, and also in the higher secondary courses you studied. So it would be very easier, but you need to practice. So I will request again, practice more and more, and it would be very easier, and this content is very interesting, I think so. So thanks for watching.